Hey guys, welcome back. In this video, we're going to cover case 2 of solving quadratic equations. So I've got all 4 up here on the left. Right now we are working on case 2, and I've standard form down at the bottom there in case you have forgotten that. So, in case 2, the only difference from case 1 is that A is not equal to 1. So if we look at the example that I have here, it doesn't match this exactly. It's not in the exact form. So what we're going to do first, and this is a good habit to get into, is we're just going to rewrite this so that it's in standard form. So I can do that by moving the constant to the left, and I do that by adding 9 to both sides. So I end up with 10x squared minus 21x plus 9 equals 0. Now, because A is not 1, I can't use the same factoring method that I used last time. So we're going to use a method called the AC method. There are other methods you can use. I will cover one other method in a separate video. So, in the AC method, we begin by multiplying A and C. So A in this one is 10, C is 9, 10 times 9 is 90. And I'm going to use this diagram over here on the left to organize some of this information. So I'm going to put 90 up top here, which is A times C. And I'm going to put the B term, or the coefficient of the B term, down here. So negative 21. So this is B. All right. Now, in these two spots, I'm going to think of two numbers that multiply to AC. So these two numbers are going to multiply to 90, and they're going to add up to, or the sum of the two numbers is going to be equal to negative 21. So just like in the last one, I'm going to start by listing the factors of AC. So the first factors of 90 are 1 and 90. That adds up to 91, so that doesn't work. 2 and 45, that adds up to 47, so that doesn't work. 3 and 30, that adds up to 33, so that doesn't work. 90 is not divisible by 4. 5 goes into 90 18 times, so 5 and 18 adds up to 23, so that still doesn't work. And then we have 6 and 15, which does add up to 21. But we want it to add up to negative 21. So it's perfectly okay to use the negative values of these integers. You could also do one negative, one positive to try and make a sum of whatever the B term is. So 6 and 15, it doesn't matter the order you write those. I'm going to write it as negative 6 and negative 15. So now what we're going to do is we're going to come back to the equation that we had been working with, and we're going to split up this B term here, negative 21x, into the sum of these two numbers. So I'm going to write this as 10x squared minus 15x minus 6x plus 9 equals 0. Now, if you think about it, I have not changed the equation because when you combine these two like terms, negative 15x minus 6x is the same thing as negative 21x. So you're changing the way that the equation is, the way it appears, but you're not actually changing the structure of the equation. All right, so now what we're going to do is we're going to group this into two different areas. So we're going to look at the first two terms and the second two terms, and we're going to factor whatever we can out of these two different groupings. So on the first two, 10x squared and 15x, I can factor a 5x out of both of those. And I'm going to write the second part of this in a different color just to highlight what happens in the last step. So I end up with 2x minus 3. And just to double check, 5x times 2x is 10x squared. 5x times negative 3 is negative 15x. And then I'm going to do the same thing with these. I'm going to factor whatever I can out of both of those. So negative 6x and 9, I can factor a negative 3 out of both of those. And what I'm left with is 2x minus 3. And what you should notice at this point is that these two binomials are the same. So if I think of this as one grouping and this is one grouping, I can factor the 2x minus 3 out of both of those. And these should always end up as the same binomials. If they don't, then you made a mistake earlier on. Or the equation's not factorable. So I'm going to factor out the 2x minus 3. And what I'm left with is 5x minus 3. Now, just like in the last example, I'm going to set both of these equal to 0 to get my solutions. So I'm going to set 2x minus 3 equal to 0 and 5x minus 3 equal to 0. And when we solve these, we should have our two solutions. So I'm going to add 3 to this one. I get 2x equals 3. And then I'm going to divide by 2. I get x equals 3/2. Do the same thing on this one. So I'm going to add 3 to both sides. I get 5x minus, or 5x equals 3. Divide by 5. Divide by 5. I get x equals 3/2. Or, sorry, 3/5. And those are my two solutions. So x is equal to 3/2 or equal to 3/5 in this equation.